All right, so this is section 3.2, and in section 3.2, we're talking about exponential functions. So we're going to talk about compound interest, the number e, and also exponential functions with the base e, and a little bit of growth and decay. So in this section, you'll be able to recognize an exponential function graphically and algebraically. You'll be able to evaluate the function, exponential function base e, and then also you'll be able to use exponential functions in compound interest and growth decay problems. So let's start off with what an exponential function is. All right, so they look like this. A raised to the x, where a is just some number, and we're going to assume that number is greater than 0. All right, so this looks a little different than like a quadratic where the x is at the bottom and the number is in the exponent. So actually the variable, the x, is in the exponent here. So that's how you know it's an exponential function. All right, and so we have two types, exponential growth and exponential decay. So exponential growth happens when our a is greater than 1. So for example, 3 is bigger than 1, so this exponential function, 3 to the x. So that's an example of an exponential function. All right, so let's talk about how we choose points on an exponential function to graph it. So let's plug in 0. I always like to do 0. That's the easiest thing to do usually. F of 0 is the same thing as 3 raised to the 0, right, for this function. We're plugging in 0 for x, and anything raised to the 0 is 1. So that means on our graph, we should have the point 0, 1. And in fact, this point is on every exponential function, a to the x, 5 to the x, 4 to the x. They all have the point 0, 1. So let's look at a couple more points. Let's look at f of 2. That's 3 squared, which is 9. What about a negative number? F of negative 1. So what would that look like? 3 to the negative 1. Okay. All right, so whenever you have an exponent that's negative, that means our problem is actually in the wrong position. It means that this 3 should be in the denominator. So this is the same thing as 1 divided by 3. All right, so when you plug in negative 1, you should get something really small, like 1/3. So there are a few characteristics that exponential functions have. So for this one, exponential growth, when we read it from left to right, our function is getting bigger and bigger. So it's always increasing. Also, it passes the horizontal line test. So this is a one-to-one function. It has what's called an asymptote. So an asymptote is a line. So I'm going to draw a dashed line. So it's a line where our function gets closer and closer and closer to it, but it never crosses it. And so the equation of this line here is y equals 0. So this has an asymptote of y equals 0. Our function won't cross this line. Also, it has the y-intercept 0, 1, and there aren't any x-intercepts because it won't cross y equals 0. All right, and so we can look at exponential decay. So this happens when our base of our exponential function, so the inside, if it's between 0 and 1. So here we have like this whole number bigger than 1. Here we have a fraction, so something between 0 and 1. And when that happens, we actually get a decreasing function. All right, but it still works the same way. We can plug in points. All right, so we can look at g of 0. So that's 1/2 raised to the 0. All right, anything raised to the 0 is 1. So we should have our usual point for exponential functions, 0, 1. That should be on the graph always. All right, let's plot a couple other points just so we can see how these work. So let's try 2. 1/2 squared. All right, so that's going to be 1/4. So we take 1 squared and we also have to do 2 squared. So that's how we get our 1/4. Let's do something negative, like g of -2. All right, so what does this mean? Okay, so again, I mentioned that whenever we have a negative exponent, that means our numbers are in the wrong place. The stuff that's in the numerator should be in the denominator, and the stuff in the denominator should be in the numerator. So this is the same thing as 2/1 squared. All right, so when we flip it, the exponent becomes positive, and we get 4. All right, so I mentioned before, this one is always decreasing, gets smaller and smaller, passes the horizontal line test, so it's 1 to 1. Also, it has the same asymptote. It has an asymptote at y equals 0. We'll not cross that line, and we also have our y-intercept of 0, 1. All right, so let's talk about different kinds of exponential functions. So our main thing that we're looking for is we have a number raised to a power. All right, number raised to a power, that's a variable. So the x is in the exponent. We can do 3 to the x plus 1. The base is 3. 1/2 to the x minus 1. So things can look a little strange here, but the main thing is that our variable is in the exponent, and that's why it's an exponential function. All right, so let's talk about examples. Number 1, is 1 to the x an exponential function? Tempting to say so because it has the right form, 1 raised to the x. But let's think about that. It's actually just a horizontal line. So I'm going to write this down. The answer is no, and I'll explain why. Because it's just a horizontal line. So why is it a horizontal line? Well, let's start plugging in points and see what happens. F of 0 is 1. F of 1 is 1. F of 2 is 1. F of 3 is 1. So no matter what happens, we get 1. So actually, this is the graph that's just the horizontal line, y equals 1. So actually, this is not an exponential function. So for our exponential functions, we want to make sure that our base is not 1. So we're going to assume that our base is greater than 1 or between 0 and 1, not including 0 or 1. All right, so looking at this example number 2, is -4 to the x an exponential function? Well, let's think about this. I want us to try f of 1/2 and see what happens. So 1/2 power. So do we know what a 1/2 power means? That's the exact same thing as the square root. So raising something to the 1/2 power is the same thing as taking the square root of that number. So can we do this? Can we take the square root of a negative? Of course not. This is undefined. So the answer to this question is no, this is not an exponential function because we can't do things like this. You can't raise it to a fractional power like 1/2.